Okay, bye.
We don't have to really go through this, just population. first one, the second one, I don't have to write the 67 second column.
No, the second part. You need to put
On the
parentheses.
first one.
You need to put parentheses here and parentheses here.
Okay, but it still came up to the same thing.
Really?
The
If
three
you just put
column.
parentheses
Yeah,
here.
the same thing.
Well, it's okay, fine. All right, maybe that'll work.
Oh, no, it's not. Mine's, oh, no, mine's don't round it. Everybody else round, mine's don't round. He got the same thing, yes, yes, okay. Thank you.
Is that code for?
It doesn't go back to school anymore.
Oh,
Thank you, Alvin. It's not allowed.
oh, wow.
It's counting glitch.
How does that? I always feel sorry for students who try to use the cell phone at work. Save yourself $15.
I mean, unless you put it further in parentheses, why can't you put it out?
There's no tax to go.
I don't need to tax those.
Alright, a couple more minutes or start? Good? Maybe one more minute, because I see some heads down.
I appreciate it. Mine's just reading the whole number, I'll be reading the whole number. You have to stop it at 3, mine's don't stop, you have to say number, mine's just keep going. Oh, yours automatically round, mine's don't. That's why I be saying it 29.
Alright, should we do this one? Let's do it. Alright, in this case, we're looking at two populations. Population of men in Scotland, population of women in Scotland, and we're looking at their income. And we might think, for some reason, that the men are making more money on a weekly basis than the women. And maybe someone's trying to tell us, oh no, that's just the people around you. Your sample might be biased. So let's do some actual research and see if we find a true mean difference between every man in Scotland and every woman in Scotland. So let's sample 1,500 men, 1,200 women, and in that sample we find that the average weekly income for men is $317, average weekly income for women is $172. Alright, what is our point estimate of difference just based on those samples?
300?
So just based on this, what would you say the difference between weekly income for men and women is?
145.
145, fantastic. So we're going to take 145 as our point estimate of difference, plus or minus some amount. Of course, that some amount is going to be based on our desired level of confidence, our z-value, that number of standard errors. So we're going to look up z-value and we're going to calculate standard error. When we look up z-value, 95%, what do we see?
1.96.
1.96, our favorite number. We now have an equation for the standard error of mean difference. What is that once we crunch through those numbers?
What, the 3?
3.003.
3.0035. 8, yeah.
Alright, 3.00358.
Yes, sir.
Fantastic. So that's 3 pounds. Alright, that's our standard error. Just put it in context. So we're going to take 145 plus or minus 1.96 times 3.00358. 1.358, that number's stored in your calculator, that many pounds. When we multiply just those two, what do we get for our standard? Wait, our margin of error.
5.8870, 5.8870.
5.887 pounds.
Well,
Yes,
Pounds,
I think she rounded up, I got 5.8869.
Yeah, that's what I got, but unless you round it
Just
up.
depends how many decimal points you
Right.
used.
Alright, good. Now, you're just gonna leave that in your store that on your calculator,
My
leave it in the
calculator
calculator.
don't, roundabout, they don't round.
Yeah, so you got a different,
I got, yeah, it's 7-0.
Huh.
It's 8870.
what does it say after that?
It's 7019144.
I got
The
168.
whole number.
Okay,
58, yeah.
so I guess they should be the same, so.
Well, I think it's just how many decimal points you use in the multiplication in the above step, yeah.
Oh, yeah. Okay, so did you keep this number in your calculator? You didn't
Yes.
store it, you didn't store it, 'cause
I
you,
put it in, because once I put it in,
no, because you don't know how to store numbers in your calculator yet. You're gonna Google and figure out how to store numbers in your calculator. Once you-
then I got the same number.
Once you do, you're gonna have the exact number of this, because this goes on forever.
Right.
Oh, yeah, it's
Right.
1196, yeah. I
Yeah,
have the
so
whole
you
number.
want this number that goes on forever, and then you're gonna multiply that by 1.96.
That's
And you're
right
still not even gonna round it at that point, you're gonna keep this whole number that goes on forever in your calculator. And you're gonna take 145 plus that, 145 minus that, and then you're gonna round to 2 decimal points after the whole numbers. And what are you gonna get for the lower bound?
139.11.
And the upper bound?
Times 3.035.
Okay. Can someone give us the interpretation?
We are 95% confident that the population mean difference is
I
between
got the same
139.11 and 150.88.
Okay. Alright, so you're 95% confident that that is the real difference between the average amount men make in Scotland and the average amount women make in Scotland. So remember in, I think, the last example, we looked at this lower bound and it got fairly close to 0. And because it got close to 0, we thought, well, you know, we're a little skeptical that there is a difference. I think in, you know, print or broadcast Democrat representation. Now, does this get very close to 0?
No.
No, it really doesn't. Like our lowest estimate is 139 pounds. So what would you say to someone who says, well, that's just a sample. If you were to test the whole population, maybe there really wouldn't be a difference between income between men and women? What would you say to that person?
That's
We
not
would
wrong.
say we're 95% confident.
We're
Yeah.
95% confident that there is a significant difference. And that it's as high as 150, maybe be as low as 139. But now what about that okay, so you're with me there? Alright, so we tell that person, no, this is the true population difference. This is an interval representation for everything. And we are darn confident that this is what it is, that it is somewhere in between these two numbers. Now let's just take that one step further. What if that person says to you, well, what about that 5%? There's a 5% chance you could be wrong, and there's really no difference between what men make and what women make.
We can go another standard deviation out.
Yeah, what would you say, Amanda?
It would be a really small difference, with 5% of it being completely off.
Yeah, so I say, you told me that you're only 95% confident, so I say there's a 5% chance that there's no difference. You shake your head no at me? What could you say to that person?
Standard
Okay,
error is
figure.
only 5.8%, so if we go out even one more standard deviation, it's not gonna be that much of a difference. And that'll cover at least 98.8.
Yeah, does everyone understand what he's saying? So, so we're at 95% now, and some skeptic is telling us, well, there's a 5% chance that there's no difference. That's not true. Because what if we go out to say 97% or 99%? What would happen if we go to say we want to be 99.7% confident?
You're gonna get a bigger range.
We're gonna get a bigger range, alright, but we don't have to go that much further to be much more, to get that extra 4 and change confidence. So suppose we wanna be 99.7% confident. How many standard errors do we need to go?
3.
Yeah, we need to go 3, right? Remember, 3 standard errors covers 99.7% of the data. So we go 3 of these times 3.00358. Alright, so we go 3 standard errors. So this is gonna get a little bit lower, this is gonna get a little bit higher. But it's just, we'll just do a rough estimate of that. So 3 times 3, that's 9. So 145 minus 9 is 136. And 145 plus 9 is 154. Okay. So now we're 99.7% confident. Are we anywhere close to 0? No. So we are darn confident that there is a true population mean difference. Any questions?
The other example that you're talking about, the lower bound being close, that was proportions.
Yes. Yes.
So if we were close to 100, you'd have the same problem. It's the same as being close to 0, right?
0 difference. Okay, so proportion 0% would be 0 difference. And in this case, $0 would be 0 difference.
So it works for the lower bound, but not for the upper. It's not comparable. Never mind. The upper bounds are different. Proportions versus.
Okay, so the upper bound for percentage, we can only get to 100%, so what does that
I'm
mean?
still getting the same thing, I'm still getting the
We
same.
can only get to
I'm
100%.
still getting the 7.
So there's, the proportion difference is 100%, so that means every single person in.
I think it's the same as having a 0 difference.
What's
Right, because you're just as far from 50%.
No, that would mean 100% of print journalists are Democrats and 0% of broadcast journalists are Democrats. That's what that would mean. That would mean every single print journalist is a Democrat, every single broadcast journalist is a Democrat.
What does 0% mean?
What?
So what is the?
What
That's what I said, never mind, it doesn't matter.
I think what he's asking is why are we skeptical when it's reaching 0, but we're not skeptical when we're reaching 100?
Yeah, thank you.
But that, because if it's 100% difference, that's a huge difference. That means that the print journalism and broadcast journalism are completely different. That every single person is a Democrat here, every single person is a Republican here. So if we're able to say there's 100% difference, then we're able to say there's a huge difference. If our interval crosses 0, then we don't know if there's a difference at all. What I just said is correct. I don't have it registered, but what I just said is correct. Okay. I don't think we need to do another one. I think we're good, right? Yeah? Alright. So I don't think I'll see you next week. I'll see you the following week. And next year, we'll just pick up right where we left off. We'll do hypothesis testing, which I think is exciting because that's when we get to put this underlying theory to good use.
We don't have class next week?
No. No class next week.
You guys are making it 99.1. You guys are 5.8, right? And then I got, no, but I have that. Then I got
All right, have a good one. Enjoy your house.
That's just, yeah, you can
Good night. Enjoy your house.
There's so many steps, there's so many places to make small errors.
As long as it's mostly done, you'll get 5 out of 5. And if I don't give you 5 out of 5 for the Excel, I'd say you the quizzes are different. Excel, resubmitted.
Amanda, are you able to see if you got
John, what I said was correct. But
Yeah, got
100%
it.
difference is important.
Got it.
But 0% difference is like, what are you gonna stand up and say, guess what, everyone, there's no difference, maybe.
But how is no difference any different from 100% different?
Because if you can say something 100% difference, you have something that I would invest in. Like you're confident that 100% of people in this market would buy your product versus no one in this market would buy your product, then I'm investing in your product. But if you stand up and tell me, well, maybe more people would buy it than this, maybe more people would buy here, maybe more people would buy here, I don't know. That's no difference. I'm not investing in that.
Got it, got it.
Yeah, no, so, okay, yeah, so.
You got it, okay,
So I'll
good.
go, I'll look at it.
Yeah, you're welcome.
1.96?
I'm trying to be like.
Yeah. I think they were saying that this though, this you need to
Come on, Ted, let's go.
number your
You got a question? I did that.
But you don't know
See you next year, have a great Christmas.
Alright, well,
I did that like 3 times.
this looks like it's gonna be close enough. But
It
I
is
would
close.
Google,
When I
I
ran
would
it.
put this in like this, and this,
Oh, no.
I'll
Thank
see
you.
after.
I like 3
Oh, wait, what were you gonna say? Tank, what was the interpretation of the last
Excuse me.
that you stated? It's not the true, it's not the.
We are 95%.